Hello, welcome back. Now that you understand the syntax of SD and SW assembly instruction, now it's time to practice debugging this assembly instruction. So what you are looking at is window of the TRACE32 debugging program. And this window is the instruction window with the address. And what you can see is SD assembly instruction and SW assembly instruction. And this is the register window. So during debugging, you are going to use another window, that is the memory view window. But before learning this instruction, let's analyze syntax of this assembly instruction. The first assembly instruction is SD assembly instruction. As we explore this instruction last lecture, this instruction works in the two steps. The first step is to identify the target address to store. For this, we have to check the value of the source register. In this assembly instruction, the first source register is S0 register. And here, so this is the offset that should be added to the value of S0 register. So this is an equation to calculate the target address to store. The second step is to store the value of the A5 register to the target address. That is an operation of SD assembly instruction. Now it's time to check the value of the S0 register. S0 register can be seen here. So the value of S0 register can be copied using some Ctrl+C button. So here we go. I just copy the value of the S0 register. This value can be added to the offset that is the 0x10. So in order to see the memory layout, and we have to use another command that is supported by the TRACE32 debugging program. That command is here. So using this command, then we can see the memory layout with the memory contents. So I will just copy this command to enter in this terminal. So let me give a hit. Please take a look at this. This window shows you the address and the corresponding the memory content. And next thing you have to check is the value of the A5 register. A5 register has this value. Please take a look at this. A5 register has this value. Now that everything is ready to perform debugging, the target address to store the data is this address. So please take a look at this. This address is the target address to store the value of the A5 register. So it's time to run this instruction to see what's going to happen. So I'm going to click. Please wait. I'm going to click. Let me arrange the position of this window. So I will choose the click the start button to run this assembly instruction, and please pay attention to the window that indicate about address and the memory contents. So here you go, 1, 2, 3. Please take a look at this. The memory contents is updated at this target address. The value of the A5 register is written to this target address. That is what we expected. So now we run the first assembly instruction. Let's move on to the second assembly instruction. And second assembly instruction is SW assembly instruction, unlike SD assembly instruction. As for SD assembly instruction, D stands for the word. What does it mean is the size of data is 8 byte. But as for this assembly instruction, size to store is the 4 byte. So as for second instruction, the first source register is the same as the first instruction, that is S0 register, but the offset is 0x20. So based on this equation, I will change the offset of this assembly instruction, and the value of the A5 register will be written to the target address. So we already calculate, we got to know about which value is in S0 register. S0 register has this value. If we added the offset to the value of S0 register, and target address to store will be in this address. So based on this, the memory window, here is the target address to store in the second assembly instruction. This address ends with the 420. The 420. And before running this instruction, we can expect that only 4 bytes will be written to this target address. So let's try it out. Here we go. 1, 2, 3. Please take a look at this. Only 4 bytes of the A5 register is written to the target address. That is the main difference from the SD assembly instruction. SW instruction support the 4 byte store operation. Now that we got to know about how SD and SW assembly instruction, the next time we're going to explore another interesting assembly instruction in RISC-V architecture.